All right, today we have the binomial theorem. We are going to be eventually expanding out binomials to some kind of larger powers where essentially we kind of FOIL these out a few times, and we got some shortcuts that we're going to be teaching you today. So we're going to get at it here. The first thing we're going to need to talk about, we'll use this a little bit later in the lesson, is we're going to talk about factorials. Theoretically, you learn this in geometry. What a factorial is where you take a number and then you multiply that number by the one lower, the number lower than it, I guess, one minus a number. So for example, like if I have 5 factorial, you're going to do 5, and then you're going to times it by 4, and then you're going to keep timesing it by the 1 less than the number there, all the way down to 1 right there. And that's what factorial is. And down here below, we're going to talk about how to simplify some of these factorial things. We use it a little bit with this binomial theorem thing coming up here in a minute. So these are going to typically be on the non-calculator section because you can find the button in the calculator and type it in, and I'll show you here in a second. But here's how you're going to do something like this right here. My approach would be this here. So if you have 9 factorial, instead of writing it all the way out here, I'm going to write it as 9 times 8 and then times 7, and then instead of writing 7 and then 6 and then 5, I'm going to write it as 7 factorial. Okay, and that's going to be because I have already a 7 factorial down in the denominator, and those essentially are going to cancel out. All right, now you still also have this other 3 factorial. I'm going to write it out kind of right here. So I can expand it here in a second. So the 7 factorials will cancel out. You're going to have 9 times 8 in the numerator there. That'll be, what is that, 72. 3 factorial is going to be 3 times 2 times 1, which obviously is, 6. And then when you divide those, that'll come out to 12 overall. Okay. Now you can also type these into the calculator. So let me show you where the buttons are for that. If this were to be on a calculator section, I think on the test, though, these are on the non-calculator. So what we're going to do is you find the 9, and then you're going to hit the math button. And then usually you can like scroll left and right. Normally it's standard to be on math. And then you're going to scroll right a few clicks here to this PRB. That stands for probability. Factorials use a little bit in the probability stuff. So, and then if you just saw that little exclamation mark right there, it's math. And then it's that 4th option down right there. So there's your 9 factorial. And then you can do divided by. Now to force a calculator to actually multiply 3 factorial times 7 factorial, you'll need to put an extra set of parentheses so it does the order of operations correctly. We'll hit math, we'll find that factorial button again, and then times 7. And then math, and then factorial. And it came out to the same thing right there. So we'll do a few more here as far as simplifying them down. So this one here, it's got some similar ideas here. So we got 8 factorial. So instead of writing 8 factorial, I guess I'll write 8 times 7, and then times 6, 5, and then I'm going to do a 4 factorial for the same reason that I did on that last one, because you can cancel out a 4 factorial. Now in the numerator, you also have a 3 factorial. Down in the denominator, it looks like you have a 4 factorial, so you can get a couple of things that kind of cancel out there. So here's what I'm going to do here. I'm going to do for the second 4 factorial, I'm going to write that as 4 and then times 3 factorial. Okay, and then that way, my leftover 3 factorial in the numerator right there, I can get those to cancel out. So I'm going to cancel out a 4 factorial. I'm going to cancel out a 3 factorial. And then we'll start kind of simplifying. I guess here, if you want to make the reducing a little bit easier, especially if you don't know 8 times 7 times 6 times 5, we could go and say, hey, 4 goes into 8 2 times. And then we can start kind of simplifying this here. I'm going to strategically do this here since I don't have a or we're going to pretend we don't have a calculator. I'm going to do 2 times 5, which is 10. And then 7 times 6 right there, that would be 42 right there. So then that'd come out to 420. and you'd only have a 1 left over in the denominator right there. So that's how you can do it. So you got to do a little bit of manipulation to kind of see if you can get some things to cancel out. Okay, this last one here is just kind of dealing with, I guess, algebraic expressions here. So technically, if you have n factorial, or n plus 1 factorial, you're going to write n plus 1, and then you're going to do n plus 1 minus 1. You subtract 1 from that, which instead of writing that, I'm just going to write it as n. And then n minus 1, and then n minus 2 after that. But instead of doing that, we can use your factorial right there. And then you already have an n factorial down in there in the bottom. And then I guess you can go and cancel out your n factorials, and that comes out to n plus 1. Okay. So we'll use a little bit of factorial here in one of our theorems in just a minute, but we'll use the calculator for most of those there. So, okay. Now this next thing that we're going to do here, we're going to use this thing called Pascal's triangle. It'll help us expand out binomials to different powers. So instead of doing this page here first, let me show you what this Pascal's triangle will look like here. The way it'll start out here is we're going to say row 0, our first row right here, which actually we don't call row 1, we call it row 0 is your first row. You're going to put a 1. Down there below, I want you to write 1 and 1, kind of like this. We're going to make this into a triangle. Row 2, you're always going to start out with a 1, and then 1 plus 1 right there, that's going to come out to 2. So I'm going to put 2 right there, and then you end with 1. Okay, row 3, you're going to start out with 1, and then the next one here is you're going to do 1 plus 2, you're going to put 3, and then you're going to do 2 plus 1, that'll be another 3, and then you don't have anything to add to the end right there, so you'll put a 1 there, and that'll be row 3. And you keep doing this process of just adding, the 2 above it, I guess, to get the next row. So row 4, you'll start out with 1 again. 1 plus 3 will be 4. 3 plus 3 will be 6. 3 plus 1, that will be 4 again. And then you'll end out with 1. Okay, and you just keep on rinsing and repeating. I think we're going to need up to row 7 today. So I'm going to write that all the way out. And I'll show you how to use this in just a second here. So row 5, you'll do 1. 1 plus 4 will be 5. 4 plus 6 will be 10. 6 plus 4 right there, that'll be another 10. And then you'll have a 5, and then a 1. Notice that each of these rows here, like row 2, the second number is a 2. Row 3, the second number is 3. Row 4, the second number is 4. So that's kind of a little trick there that you can see to see if you're doing it right. Okay, row 6, you're going to have 1, 6. 5 and 10, that would be 15. 10 and 10, that would be 20. 10 and 5, 15, and then 5 and 1, you'd get 6, and then you'll end out with 1 again. Okay, and then finally, we're going to just do up to row 7 today. That's all we're going to need. So that'll be 1, 7, 6, and 5 there. That'd be 21. 35 with the 15 and 20. Another 35. 21, 7, and then 1. Okay. So that is how you make this Pascal's triangle. Okay, and this is going to be tied out to the binomial expansion. So we're going to fill out a little chart here on the previous page here. So here's what we're essentially looking at here. I guess here, let me read this here to you. You have seen binomials, algebraic expressions involving the sum of 2 unlike terms repeatedly since Algebra 1. You will now see them as a series that is the result of a binomial raised to an integer power. When this happens, you'll notice that the coefficients of the series have a predictable pattern. That's that pattern that we're going to see on that that we've already seen on the other page there. Let's start by looking at what happens when we raise the binomials to consecutive integer powers here. So first thing you're going to put here is a plus b, and then you're going to raise it to 0. And technically, if you were to expand that out, it's going to be 1, and then a to the 0, and then b to the 0 right there, which, I mean, really that just equals 1. Okay, if you did a plus b to the first power, there's really nothing to FOIL out, so it's going to be 1, and then a to the first, b to the first, or I'm sorry, and then b to the 0th. And then the second one here will be 1, a to the 0th, and then b to the first there. So it's really, it simplifies to just a plus b, like on this one here. Okay, but kind of pay attention to those powers there. All right, if we had a plus b and then squared, here's what you're going to do here. You're going to write 1, and then it's a squared, b to the 0th, 2, a to the first, b to the first, and then back to 1, a to the 0, b to the second. All right, and where these coefficients are actually coming from here, that's going to actually be row 2 on your Pascal's triangle. So if we go back here and look, here's row 2, 1, 2, 1 right there. Row 1 that we had before, we had 2 coefficients of 1. So here in a second, we're about to have 1, 3, 3, 1. And then notice here how your powers essentially always need to add up to your exponent here. So if you have a 2 right there, these two need to add up to 2. These two powers need to add up to 2. And then these two powers need to add up to 2. Okay, let's try out row 3. So when you expand a plus b cubed, before we would just have to FOIL that all out together. Now we're kind of learning this new little pattern here. It's going to be 1, 3, 3, 1 according to your Pascal's triangle pattern. Now your powers will need to always add up to 3, so the first one will be a to the 3rd, b to the 0th power. Second one is going to be a squared, and then b to the 1st. That adds up to the powers of 3. Next one will be a to the 1st, b squared. And then final one will be a to the 0th, and then b cubed. And you just put little pluses between all these here. And I'm not really going to simplify them. I'm not going to take care of this b to the 0th. I'm just kind of leaving it like that there, for now, I guess. All right, let's do 2 more rows here. So you have a plus b to the 4th. That row from your Pascal's triangle is 1, 4, 6, 4, 1. Notice there's a lot of symmetry with these here. So 1, 4, 6, 4, and then 1. All right, and then as far as what are your powers, it'll be a to the 4th, b to the 0th. As long as they add up to 4, you're good. And you'll go cubed, and then I guess that would be 1. A squared, b squared, a cubed, or I'm sorry, no, a to the 1st, b cubed, and then a to the 0th, b to the 4th. All right, now, so with row 5 here, we'll go and do a plus b to the 5th. So let's go look at our triangle here to figure out the coefficients. 1, 5, 10, 10, 5, 1. Go ahead and write that. 1, 5, 10, 10, 5, and 1. And I'm going to show you the way I kind of like to do these here where I can do them quick. So remember, your powers always need to add up to 5. So we'll start out, and I'll just actually do this here. I'll write all the powers of a. A to 5, 4, 3, 2, 1, and then 0. And then now I'll go and start with b over here, and I'll go 5, 4, 3, 2, 1, 0. And that just helps kind of speed me up there when going through these. That's how you can expand these out here. So now here's the thing with these here, we're going to actually expand binomials like we'll do with our 7th row here in a second, but then we'll start throwing in things like 3x and 2 instead of just like a's and b's and stuff like that, so that'll get a little bit more tricky there. So let's make a few observations here. Each expansion actually has, instead of n terms, we'll say it has n plus 1 terms. So like your different powers there. So like, for example, your 5th row to the 5th power has 1, 2, 3, 4, 5, 6 total terms. So that's what we're saying there. The first term will be the a to the nth. And then the last term will have b to the nth power, whatever those a's and b's are. In successive terms, the power of a decrease by 1, and then the powers of b increases by 1. We can kind of see that pattern going on. The sum of the exponents, I kind of mentioned that if you didn't catch it, the sum of the exponents will always add up to your exponent right there. And then the coefficients increase and decrease in its symmetric pattern, which I've also kind of mentioned. They're all symmetrical there. Okay, now we already kind of went through this Pascal's triangle here. That's actually what goes in the blank. So I'm not going to really go back through that again, but we saw how to make the triangle there. I guess my 1 got left off right there. So now let's use a Pascal's triangle there to go and get row 7, which is actually right there above. So we'll expand kind of the same thing how we just were doing that table there. This one's just got a lot of coefficients here. You're going to have 1, 7, 21, 35, 35, 21, 7, and 1. Now your first thing will always be your A, and your second thing will always be your B. That'll come into play a little bit later here, but on this first one, it's kind of easy. It's just A needs to be 7 right there. So, and then I'm going to do that same trick I did earlier. A 7, 6, 5, 4, 3, 2, 1, 0. Then go back with your powers of B. Let's see here again. It was power of 7, right? So 7, 6, 5, 4, 3, 2, 1, 0. And then you'll put pluses between them. They're actually not always going to be pluses. We'll see some here, hopefully in a minute, where you're going to have some negatives there. And that's how you expand that thing. And some people might simplify like this first term here. If you want, you could just write it as, a to the 7th, and then you don't really need to write b. So you can write a to the 7th b, and then 7a, 6b, 21a, 5b squared. So, I mean, basically there's like 1 or 2 of them that you can simplify. We'll actually have quite a few of these here later that'll simplify down a little bit more, so there'll be usually a second step on a lot of these. I guess I could have copied and pasted, but oh well. This last one, instead of writing 1a to the 0th, I'm just going to write b to the 7th like that right there. So that would be what happens if you FOILed out a plus b to 7 times right there. So here's where it gets a little bit more interesting, is when your A thing is going to be 3x, and then your B piece is going to be 2 right there. So this will be a lot more interesting here going on. So I'll show you how to attack these here. So we got a power of 4, so we're going to go use row 4 here on your Pascal's triangle. Okay, so we'll try that out here. So the coefficients there, I got it off screen here, so I'm kind of writing here. Whoops. You got 1, 4, 6, 4, and then 1. Okay, so now our A is going to be 3x. So I'm going to go parentheses 3x. And I like to go ahead and write out all the 3x's here. Really here, I'm going to write out 3x, and I'm going to write out the 2, and then we'll go get the powers here in a second. So these are our A's and B's, 3x and 2. And then now these are the things that are going to have your powers here, and they got to add up to 4. Your first power will be 4, your second power will be 0. And these will always add up to 4. So you can go the 4, 3, 2, 1, and then 0. And then you can go the 4, 3, 2, 1, 0. Okay. And then right now we got pluses in between them. everything will be positive. And then we're going to go and simplify these down here. So the way this works here is you're going to multiply 1, and you need to multiply times 3 to the 4th. And then 2 to the 0th is just going to be 1 here. So it's really, I mean, if you wanted to type it into the calculator, regardless of what all the things are, you just go 1 times 3 raised to the 4th, and then times 2 raised to the 0. Hang on, I didn't type that in right. Need to get out of my exponent. Okay. And then times 2 to the 0. 2 to the 0, I mean, honestly, it's just going to be 1 anyways. So really, it's 3 to the 4th right there. Overall, it's going to be 81. So you're actually going to write here, this thing simplifies to 81. And then you still have x to the 4th right there. 81x to the 4th is what that simplifies to. Next one here, it's going to be 4, and then times 3, and then raised to 3. All right, because this part right here, 3x cubed right there would actually be 3 cubed. That would be 27, and then x cubed for that part. So instead of doing that, I'm just going to do 4 times 3 cubed, and then we'll worry about the x part later. And then really, it's actually 4 times 3 cubed, and then times 2 to the 1st, which 2 to the 1st is 1 anyways. So that'll come out to 216x, and then cubed. And remember, our b part right here, that's just a whole number right there. So b is, you're not really going to have a second variable, I guess, on these. Okay, let's try this next one here. So I'm going to kind of do the same idea. I'm going to do 6. I'm going to do times 3. Okay, and then I'm going to raise that to 2. Get out of your exponent and then do times 2 raised to 2. And then that'll come out to, happens to come out to 216 again. But then that'll be x and then squared. Okay, next we'll have 4 times 3. I mean, honestly, we could probably do this mental math. 4 times 3 to the 1st, so that's 12. And then this will be 8, so 12 times 8, that'll be 96. So some of them might be small enough to where you can do without a calculator. Next one here, anything raised to 0 is 1, so this is kind of like 1 times 1, and then times 2 to the 4th. 2 to the 4th, I think, is 16, so those should be plus 16 here at the end. And that is how you expand the binomial like that. And basically, it's just kind of rinse and repeat. It's not going to be drastically different on each one. The only thing that can change things a little bit is if you have a minus in your binomial, which is what we're going to see here on this next one. So we'll give it a spin here. So we'll need row 5 here on this one here since your power is 5. So here's what we'll do here. I think the row here is going to be 1, 5, 10, 10, 5, and then 1. Just make sure you leave enough space to get everything else. Okay, so here's going to be your thing. So you're going to do x as your first part, and then actually you're going to do negative 4y. That'll be kind of your b part. So this will be your a, and then the negative will go with the b part right there. So the negative will go with the 4 right there. So here's what I'm going to do on each of these here. I'm going to write times x, and then times negative 4y. I'll go get the powers here in a second. So we're just going to kind of rinse and repeat there. X, 4y, get the powers here in a second. Okay, then after that, I want to go back and get my powers. They'll all need to add up to 5. And then you start and you just decrease them. 5, 4, 3, 2, 1, 0. 5, 4, 3, 2, 1, 0. For now, put pluses between these, but when we simplify some of these will eventually simplify to a positive, and some of these will eventually simplify down to a negative. So that's the full thing unsimplified, and then from here, we're going to go ahead and multiply everything. Now the coefficient for that 1x right there is just 1, so really this is going to be 1, and then times 1 raised to 5, which is still going to be 1, and then negative 4, you would need to put negative 4 in parentheses and then raise to 0, just like that. So that should come out to 1. You don't have a y, so you'll just have x to the 5th, and that'll be it. We don't have a y because it's y to the 0. Okay, so this next one here, oh, you know what? I forgot all my negatives with my 4y. Notice that, because that'll make a pretty big difference there. Glad I caught that early on. Okay, sweet. So the next one here, this will be 5, and then 1 to the 4th isn't going to really change anything, and then it'll be -4, but then raised to 1. Now, if you raise a negative to an odd power, it will change to a negative, so it eventually becomes negative. I change that right there. -20. You'll have x to the 4th, and then you'll only have a y to the 1st. So remember, those powers should add back up to 5 right there. So because we raised the negative to an odd number, this term becomes negative. Watch what happens when you raise it to an even number here. If you do 10 and then times -4, if I can type it right, and then close parentheses, raise to 2, -4 squared, that'd be 16. 16 times 10 would be positive 160. And then you'll go x cubed y squared. So really the signs, in a way, they're going to alternate each time. I think this one should be a negative here. This will be 10. You don't have a power or a coefficient for x, so we'll skip to the -4 and then raise to 3. For -4 raised to 3, I think 64, so -640. That sounds about right. And that'd be x squared y cubed. Just kind of rinsing and repeating here. This would be 5 times -4 and then raised to 4, 1280. And then x to the 1st, y to the 4th. And then finally our last term right here. This one I think will be a minus here. Yeah, because this is basically 1 times -4 and then raised to 5 right there. So minus 1024 right there. There's no power of x, but there's a y to the 5th. That will be your 5th row right there. So that one's got the negative, so be kind of careful there when you get the negatives going. Alright, so got a little bit more here, a little bit longer today. So you have this next thing coming up here, binomial theorem. So while Pascal's triangle is great for expanding binomials with smaller values of n, it's not very efficient if you have to draw a triangle with 25 rows. Therefore, the explicit formula is a little bit more useful here for this. So the formula for a binomial coefficient, this is just the coefficient part, by the way. So for the coefficient, or the number out in front, the binomial coefficient for the a and then n minus r and then b to the r term in the expansion is given by this thing right here. So this is NCR. There's a button for this here in the calculator, and you can use factorials to expand it out, and I'll show you how to do that on one example, but there's also a button in the calculator that does all the expansion for you. Okay, some vocabulary things, a notation, NCR, and then if you do this like N and then R with little parentheses or little bracket things around it, those are both read as the combination of N things taken R at a time. And then this little hint here, I think this is important. To find the binomial coefficient of the kth term in an expansion of the form a plus b to the n, use the formula, the NCR, and let R be whatever your k minus 1. Let R be the k, I guess, minus 1 right there. So I'll show you kind of what that means here in a second. So here's what we're going to do. We're going to find the coefficient of the 5th term in the expansion of this, a plus b to the 7th. So we've already expanded that on a previous page, so we're going to use this to check here. So here's what we're going to need for this here. When this happens, we'll do the n and then the combination and then the r right there. So n and r are going to be numbers that we actually input here. N is the highest power, so that's going to be 7. I'm going to write that down just for our notes. N is the highest power. Okay, the R, we have that formula up there, so we're going to do the kth term, or the 5th term, minus 1. So R is going to be 4. It's the kth minus 1 every time for that. Okay, so we're going to use 7 and then do the combination process and then 4 right here. So if you kind of look up there at the top, they have a process for it using the factorials. So we're going to put the 7 factorial in the numerator. you're going to do 7 minus 4, whatever that is, and then you're going to do that factorial. And then also in the denominator, you're going to do the r factorial, which was 4 factorial. Okay, so if we write this out here, once again, there's a button for this in the calculator. This is what this thing simplifies to. And then we're going to, without a calculator, we would use this to, kind of expand things out here. Instead of writing the full expansion here, I'm going to write 7, and then times 6, times 5, and then I'm going to put 4 factorial after that. So the 4 factorials cancel. The 3 factorial, I'm just going to go ahead and write that out. It's 3, 2, and 1. Which honestly, you don't even need to write the 1 right there. 4 factorials should cancel there. Let me see if I can be kind of strategic here on this here. I guess I could do 6 times 5. That's 30. 30 times 7 would be, was that 210, I think? And then down in the denominator, you'd have the 6. And then you can cancel. Actually, you know what? This would have been easier. Check this out here. We could have done this here. 3 times 2 is 6, so those would eventually cancel out, and then that'd just be 35 over 1, which comes out to 35. Okay, so that is actually your coefficient on the 5th term in that expansion. We're going to go and double check that here by looking at the one that we did. I think that was example A. So they wanted 5th term, 1, 2, 3, 4, 5. There's your 5th term right there. Notice how you have a 35 out in front. Okay, and that's super useful for like if I want to do like the next example, like the 13th term. Okay, now this one's a little different. We're going to find the coefficient of the 3rd term in this expansion. Oh, okay, so we just need the coefficient. Sometimes they're going to ask for the coefficient. Sometimes they're going to actually ask for the full entire term. I think I might just show you all that. Let me see. I think that might come up anyways. Yeah, I'm going to show you how to do just the full term. I'll show you the coefficient and the full term, I guess. So really the instructions just say the coefficient. So we'll kind of do the same thing, and I'll show you all the buttons here in the calculator. So the n in our case here is going to be 13. Our r value is going to be, let's see here, what term? 3rd term, and then minus 1 from that right there. So r is going to be 2 in this case. So we're going to do 13 and then c and then 2 right there. So there's a button in the calculator. We use it a little bit in geometry. If you hit the math button, and normally you're under math, you need to scroll to the probability part. And there is an NCR button right there. So go ahead and click that. In this app, the top number you put in is the bigger one, I believe, and then the bottom number is going to be the smaller number. I think on a normal calculator, it'll look more like this, and you put 13 first and then 2 second. If you do it the other way around, it gets you 0 anyway, so you'll kind of know you inputted it in incorrectly. So anyways, it comes out to 78 right there, and that should be your coefficient right there. Okay, so now I'm going to do a little bit of an extension here. I'm going to show you guys also how to find like the specific full term, because sometimes they'll ask you for that in these here. So let's see if we can actually find the full 3rd term, not just the coefficient. So it'll start out kind of like this here. You'll do 78, and then you're going to put your a and negative b. And then as far as like how do you know what the powers are, there's a little trick here to get this first power. The first power, what you're going to do is you're going to do your power 13. Then you're going to subtract 3 from that. And then you always go back and add 1 no matter what. So I guess if you want to write out some letters here, this is going to be, I guess, your n value, and then minus your 3rd term, so minus the term, and then you always add 1 onto that right there, and that'll always get you your correct power right here. So in this case here, if we do 13 minus 3, that's 10. 10 plus 1 right there will be the power of 11 right there. So that's the power that we're going to replace this with here. And then don't forget that your powers should always add up to 13, so you would need a squared right there. I guess another way to think about it is that r value we got would be that 2nd one. I think that's pretty consistent right there as well. Okay, and then after you do that, you can do, okay, 78, a to the 11th. If you do b squared, or really negative b squared, that's going to become positive, so that would be b squared with a positive 78 out in front right there. So that would be the term, and then this would be the coefficient, because I think you'll do a little bit of both there on your homework. So I wanted to make sure you guys were good there on that. All right, next one coming up here. This one is asking kind of the same thing in a slightly different way. They say find the coefficient of the x to the 7th and then the y squared term with this expansion right here. So finding that coefficient. So we don't actually know the r value would be a little bit trickier to go and find here. So we'll kind of use an idea here from the previous thing. So here's the big idea, I guess. First of all, the n, that should be the 9 right there. That would be highest power. Okay, r will actually kind of tie to that last power right there. That's kind of what we figured out on that previous problem right there. Your r was going to be the second power, so your r is actually going to be 2 right there. Okay, and then since you find that there, then we can go and use that button in the calculator there. So I'll hit the math button again, do the probability side, and then find the NCR. And we'll do 9 and then 2. We'll let the calculator do that for us. So 9C2 right there comes out to 36. So that's your coefficient. If you want the full term, which you got to do in the homework anyways, might as well show you. You're going to go and do, the first thing is going to be 4x. We'll get the power here in a second. The second one's going to be negative 3y. And then actually, you know what? They kind of already told us the powers in a way. You can put a 2 there, and then a 7 there. And then to go and simplify that, we'll go and do 36. We'll do times 4 raised to 7. And then after that, we'll do times negative 3. I think I need a times there. Yeah, we're good. Okay, negative 3, and then raise that to 2. Since that is being squared right there, it should come out of a positive number. Yep, there it is right there. So that's a big giant number there, 5,308,416. And I guess that would be x to the 7th, y squared right there. That would be that full term right there. All right. Got 2 more here. So we can use the binomial the theorem to expand each binomial. So you can do the NCRs and stuff like that for each of the pieces. Honestly, this is not the most efficient way to do these. I still would use the Pascal's triangle, especially if you have one handy. I mean, on the test, I'm going to instruct you guys anyways to make a Pascal's triangle. So this is not the most efficient way to do this here. But here's what they technically want us to do here. The theorem says your coefficient is going to be NCR every time. So the first one you do the n, whatever the power of n, and then you do, I guess for the first one you do an r value of 0. The second one you'll do n, and then the power, or the r, you'll do 1, and you'll just keep doing that, and you'll keep increasing that power until the very last one here. You should have NC, and then whatever that n is again right there. So let me show you kind of what we mean here on this one. This first one here, when you expand it out here, your coefficient's going to be 4, and then c, and then 0 here. And then you'll have the 3x, and then the negative y. Okay. And then we'll go and get our powers here in a second. I like to do the powers at the end. Second one, you'll do 4c, and then 1. And then 3x, negative y. We'll get the powers in a second. Next one, 4c2. 3x, negative y. Okay, 4c3, 3x, negative y, and then finally 4c4, 3x, and negative y. And then now let's go back and get our powers. Our powers need to add up to 4. So we'll go 4, 3, 2, 1, 0, and 4, 3, 2, 1, 0. And then you can just use the NCR button a bunch of times. I'm probably just going to show you, one or two of them typed in, but then I'm going to just copy the notes, honestly. So, like I said, it's not the most efficient way there. So actually, when you do 4 and then C0, it should actually come out to 1. And then 3x to the fourth would be 81. And then y to the 0 is just going to be y to the 0. So this thing will simplify to 81x to the fourth. Okay, next if you do 4 math, NCR, oh yeah, you can type in the number first if you want, and then do 1, you'll get 4, so then you'll have 4, 3 cubed, and then negative 1 to the first, and that'll come out to minus 108, and then that'd be x cubed, y to the first, and then rinse and repeat. Watch this here. If you hit second enter a few times, you can actually go get your NCR retyped out and then just change the number to a 2, I guess. Kind of speed things up here. That'd be 6, 3 squared, negative 1 squared as far as the coefficient, the true coefficient. 3 squared. Negative 1 squared is going to just be 1 right there, positive 1. So this will be positive 54, x cubed, y to the x squared, y to the squared, y to the second as well. And then I'm going to go ahead and just kind of speed through the rest of this here because it's pretty much the same here. The next thing will be 4, 3x squared, or 3x to the first, negative y cubed, and that will come out to, it'll actually be negative here, negative 12x, and then y cubed. And then the final one will be 1 again, anything raised to 0, 0, and then negative y to the fourth. So that'll be a positive y to the fourth. So that'll be that. And then kind of like I said, it's not the most efficient way in my opinion. To me, it's a little bit easier. If you have a Pascal's triangle already made, it's much more efficient just to look at that to get your coefficients instead of doing this NCR button a few times. But you can use it. That is useful there. So, all right, this last one, I'm going to actually use Pascal's triangle on this one here for the coefficients. And this one's kind of got this weird thing because you got this q squared, so the powers are a little bit wonky here at the beginning. So, like I said, you can do the NCR button here, but I'm going to use the Pascal's triangle. This is power of 5, so I know eventually I'm going to have a 1, a 5, a 10, another 10, 5, and then 1 eventually. Okay, and then we'll go 2p, q squared in the parentheses. This is kind of weird here. 2p, q squared. 2p, q squared. Probably just copy and paste this. Probably should, but oh well, almost done now. Okay, and let's go get our powers. All got to add up to 5. So 5, 4, 3, 2, 1, 0. 5, 4, 3, 2, 1, 0. Okay, and then we'll start to simplify these here. Where we got to be a little bit careful, the q doesn't have a coefficient, so that part's not too bad. Guess this will be 2 raised to the 5th. Let's try that again. 32. Oh yeah, of course. So you'll do p to the 5th, and then when you distribute in your power, you got to remember you multiply those. So that's like q to the 0th, which means it's just 32 p to the 5th. We'll see a little bit more action here a little bit later, but 5 and then times 2 to the 4th, and then q squared to the first will stay as q squared. So this is what's kind of weird here about these. This will be 80, and then p to the 4th, and then it'll be q squared. And I know those powers don't necessarily add up to 5, but it's because you have this q squared that we're starting out with anyways. So that kind of makes things a little bit weird there on that. So just, kind of be careful, I guess, on that. Next one here is going to be 10 times 2 raised to 3, and then times, I guess that's it right there. That'd be 80 again. That was a coincidence. And then that would be PQ, and then watch here. You got to distribute or multiply your powers. This will be Q to the 4th right there. You're multiplying, not adding, though. Okay, next, this one would be 10 times 2 squared right there. 2 squared, that's 4, so that should be 40, I believe. And then P squared, and then watch this here. Once again, multiply. This is where you actually kind of see it here. That'll be multiplied. That'll be Q to the 6, I guess. All right, getting close here. 5 times 2 to the 1st would just be 10. So 10p to the 1st, which really you don't even need to write. And then multiply your powers here. This would be Q to the 8th. And then in final one here, anything raised to 0 will be 1. 1 times 1 is 1. And then your power, when you multiply that, that will be Q to the 10th right there. That would be that full binomial expanded. That'll be it here for your lesson.